All right, chemistry students, we're going to go ahead and do a few examples from the shape worksheet number 2. Okay, the first one that we have here is BE-I2. So we have BE and I as the two different kinds that we have, kinds of atoms. And we see that BE is found here in group number 2. So that means that it has 2 valence electrons, and I is in here in group number 17. So that means it has 7 valence electrons. So BE is going to have 1, 2, and iodine is going to have 1, 2, 3, 4, 5, 6, and 7. Okay, so our electron dot structure, since BE has 2 solo electrons, that's going to be the one that goes in the middle with its 2 electrons, valence electrons, and then iodine is going to be right here. Iodine, actually let me go ahead and change the color here for this. So iodine has 7. 1 creates a covalent bond with beryllium. 2, 3, 4, 5, 6, 7, and then the other iodine, one of the electrons creates a covalent bond with beryllium. 2, 3, 4, 5, 6, and 7. Structural formula for this will be BE. That line represents the covalent bond. Iodine, another covalent bond, iodine, and that's what it looks like. Beryllium, the atom in the middle, group 2. That group 2 is linear, which is 180 degrees, and that is nonpolar. Nonpolar because the central atom has the same atoms, the same kind of atoms, matching atoms that surround the central atom. Next one is POI2. Okay, POI2. So we've got PO. I know that iodine, we just did iodine, has 7 valence electrons, so we don't need to look that one up again. Okay, but what is this PO? Here it is right here. PO is in group number 16. Okay, that's polonium for group number 16. Okay, so that's 6 valence electrons. And we're going to put that 1, 2, 3, 4, 5, 6. Okay, so since it has 2 by itself, that's going to be the one that goes into the middle. So we got PO. I got 1, 2, 3, 4, 5, and 6. And then iodine is going to match up. Remember, no single dots. Single dots want to create bonds. So we've got, it creates a bond here with iodine. 2, 3, 4, 5, 6, and 7. And creates another 2, 3, 4, 5, 6, and 7. Okay, so that is going to look like PO, covalent bond, PO, covalent bond, and then these are the extra electrons, the unshared pairs of electrons for polonium. Group 16 creates what's called a bent shape. Group 16 is a bent shape that is a bond angle of 105, and group 16 is always a polar molecule. Okay. Next one we have is CH3OH. So we've got carbon, hydrogen, and oxygen. Carbon is a group 14, 4 valence electrons. Hydrogen group 1, 1 valence electron. Oxygen group 16, 6 valence electrons. Okay, so carbon, 1, 2, 3, 4. Hydrogen 1. Oxygen 6, 2, 3, 4, 5, 6. So we have carbon has 4 singles, hydrogen 1, oxygen 2. So carbon is going to be the central atom with its 4 single dots. Remember, all single dots want to combine. So we have hydrogen, let's change the color here. Hydrogen with its 1 single creates a bond there. CH3, there's 3 hydrogens there, get another hydrogen. And then oxygen with its 6, let's change the color again here. Oxygen, 1, 2, 3, 4, 5, 6. And then hydrogen, there's 1 more hydrogen, and it will create a covalent bond right there. So that's what that looks like. And we can draw this as carbon, hydrogen, covalent bond there, covalent bond. Remember, each covalent bond, each line represents a covalent bond, and that represents 2 shared electrons. Another covalent bond with oxygen, oxygen with hydrogen, and that's what that looks like. Okay, central atom carbon is a tetrahedron. (109.5), and this is polar because we don't have matching things around the central atom. Okay, let's take a look at one more. AlF2Br. Al, F, and Br. Okay, so F is group 17, Br is group 17. Those are both, they both have 7 valence electrons. Aluminum is group 13, 3 valence electrons. Okay, so we have 1, 2, 3, and these are going to have 7. Let's give us a little space here. Fluorine has 7, bromine has 7. Okay, so aluminum is going to be at the center because it has 3 solo dots, whereas fluorine and bromine each have 1. So we have aluminum at the center. Okay, 1, 3 valence electrons, and let's put change our color here. We have fluorine with 7. 1, 2, 3, 4, 5, 6, 7. F2, so we have another fluorine. 1, 2, 3, 4, 5, 6, 7. And then we have a bromine attached to this as well. So covalent bond there. 2, 3, 4, 5, 6, and 7.
I would need to, due to circumstances across the community, I think it's a very good idea for everybody to head home as soon as you possibly can.
We have aluminum at the center for our structural formula. Aluminum, fluorine, fluorine, and fluorine. Okay, and each one has 3, 4, 5, 6, 7, 2, 4, 7 there, And
you're going to want to be with your families. Thank you, everybody.
7 there. Our shape for group 13 is a trigonal planar. Trigonal planar is 120 degrees. And this is going to be polar. This is going to be polar. We have group 13 at the center, which could be a nonpolar. But since they're not matching, we have 2 fluorines. Oops, I made a mistake here. Let's back up and correct this here. I put 2 fluorines. I put 3 fluorines, but actually one of these was bromines. Okay, so I just made a correction to this one right here. Okay, but since they're not matching, we've got bromine and fluorine around the central atom. That's going to create a polar molecule. So if you have any questions on this, contact your teachers, your chemistry teacher, and good luck.